giving us the opening prayer?
Sure.
Awesome.
Dear Heavenly Father, we're grateful for this day and for the opportunity to meet together to talk about our class, and please help us as we do so that we may learn and grow and have a greater understanding of these principles that we're learning. We love you. We say things in Jesus Christ. Amen.
Amen. Okay. So, all right. Okay, so did we all understand part 1, or Corinne, did you do it at all, or did you not just do part 2, or where did you at?
I didn't do it at all. I just
Okay.
haven't had time.
That's okay. Do you want us to just kind of walk through it together then, or?
Is it, because it looks like it uses that formula, right? The u over the divided by the square root of standard deviation?
Yeah, that's pretty much all it is. It's pretty, I thought it was pretty simple. I can just go ahead and go over the answers. That way we're all going to make sure we're on the same page.
Well, Matthew, I don't know, does he prefer to? Anyway, he wanted us to talk about, did you see that email? He wanted us to talk about that because he wanted us, because he didn't quite, I need to go back and look at that email. He said he didn't quite understand. Let me go.
I didn't quite
understand that there was.
Okay, well, I can explain it if I can find what the formula is actually called. Let me see. Is it just the z-score formula?
He said, I was wondering if you would be able to explain briefly how the square root in the problem works. I don't fully understand how that works in the whole problem. So.
Okay. So, Matt, even though you're not here, I'll try to answer your question for you. Basically, it's using the z-score formula that we used from lesson 5, and that's the formula for a parent function. So the only thing that's different is now we're using the z-score to find the distribution of a sample size. And so when we're dealing with the sample size, the only thing that changes, like the mean stays the same for the sample size. So if the average is the same in the parent or the mean for the parent function is 4, then the mean for the sample size will be 4. The only difference is that the standard deviation changes. So when you're doing with a parent function, you just the formula is x minus the mean and then divided by the standard deviation. So that's for the parent function. For a sample function, it's x minus the mean divided by the standard deviation, which is then divided by the square root of n. So so basically, you have to kind of do it in order so that you don't kind of mess up. But I'll do the square root of n first, find out what that is. So if it's 36, then the square root will be 6. And then if the standard deviation is 5, then it's just 5 divided by 6. And when you get that answer, then I do the top part. So then I do the variable, which could be, I don't know, 4 minus the mean. Well, then you get that answer, and then you just divide the 2, and then that will give you your z-score, which then you can plug into the applet to figure out the distribution and greater than or equal or less than whatever percentage and percentiles. So hopefully that makes a little bit more sense. If not, you can email me and see if I can give you a better clarification. Does that make sense to you guys?
Yeah.
Are you all concerned about that?
Yes.
Okay. All right. So question 1 on part 1, we'll just go over it together. One of the 2 conditions must be satisfied in order for a sample mean to be normally distributed. What are the 2 conditions? So do you guys remember what the conditions were?
That the parent population is normally distributed, so the sample mean is automatically normally distributed.
Okay. There's one. And the second one?
That the sample size is large, and the central limit theorem implies that the sample mean is normally distributed.
Very good. And then for this class, as long as the sample size is greater than 30, then it'll be a large sample size, large enough. So, Corinne, did you get that? You're good? Understand?
I am. Mm-hmm.
Okay. And then number 2, what is the z-score formula for the sample mean that is normally distributed? So that's pretty much if you just write down the z-score, which I just wrote it in because I didn't know how to do the symbols, so I just wrote it. Variable minus mean divided by standard deviation, which is, and I put in parentheses, for sample size, you have to do standard deviation divided by square root of n. So, and if you guys aren't clear on something, just stop me. Otherwise, I'll just keep going and assume that you guys understand, okay?
Yeah.
Okay. Number 3, suppose normally distributed population has a mean of 10 and a population standard deviation of 5. What is the probability in randomly selected individual observation is between 5 and 15? Did you guys know how to do that one?
Yeah, 68%.
Okay, good. And
It also says or 0.6827 for the exact. Is that the z-score?
yeah.
Okay.
Mm-hmm. So I kind of forgot how to use the 68 rule. 68, 95, something like that. So I guess some people do it that way. Maybe it's shorter. I don't know, but I liked the z-score formula because I remembered it. So I went ahead and I did the z-score one. And then the 40th percentile, I'm not sure because I thought all you needed to do was do like 0.40 in the area, and it would give you like the z-score for it. But I'm not sure how to do it with that one. So, did you guys at all? No idea?
No, I see where they got the 10 minus 5, but I don't understand
See, I
how
don't
they
even
get the
understand
number in the
that.
parentheses.
Yeah. Where are they getting the 10 minus 5 from? Like, why would they do that?
Well, the mean is 10. I mean, the standard deviation is 5, so it would be 10 minus 5. I don't know.
Huh. Maybe we'll have to post on the board and maybe anyone else can answer that one because it's not the quiz, right? So it's not cheating.
Right.
Okay. So maybe I'll post that. I'll post that on the board when you write it up. Sorry guys, I have allergies, so I sound like a frog and everything. Alright, C, what is the z-score for an observation of 18.5? And so you just plugged in 18.5 for your variable, and then you did the z-score formula. And hopefully you came up with 1.7, right?
Yeah.
Alright. Are you good, Corinne? Am I going too fast? If I am, I apologize.
Oh, you're fine. I have to figure things out, so I'll probably go back over and do this all by myself so I understand it.
Okay. What is the probability that an individual observation is greater than 12? And then you just plug in 12 for your variable, and then solve for your z-score, and then whatever the z-score is, you want to shade above that on your applet. Is that what you did, L'Oreal?
I didn't really know how to do that one. I got the z-score, so you shade to the right.
Right, because it's asking for greater than 12.
Okay.
Sometimes it's a little tricky because sometimes the z-score is negative, and so you want to shave like only the positive one. But if the z-score is negative, you want to make sure and highlight from the negative one and above. So it just kind of depends wherever your z-score is. Just be sure to make sure you understand, okay, this is a z-score for 12, and they want either less than that or greater than that kind of thing. So, so does that make sense? Were you able to get the right answer when you did it on the applet? Okay.
Mm-hmm.
Perfect. And then sometimes, like, the applet rounded, like, because we were always told to, like, round it to the 3/3 slot or whatnot, and sometimes the key doesn't do that, or it does, like, 1 or 5, like, and so I'm like, well, I'm just going to stick with doing 3 because that's what we're told, but the key always confuses me because it always rounds not what we're told. So I'm like, I'm just going to stick with 3, so I always do the 3 points. Unless it says round than 1, then I'll do 1, but anyhow. Okay, and then so the E, what is the probability that an individual observation is less than 8 or greater than 12? Did you guys understand that one?
So is that the 65%?
No.
I don't know. Maybe you can use that formula. I didn't. I just stuck with the z-score because that's kind of what the homework was. So I just found the z-scores for those, and they're the same. I don't remember what it was. Hold on, let me see. I think it was 5. I think the z-score comes out to be -5 and 5 or something like. Or no, it's not. Hold on. It's
-0.5.
Yeah, maybe that's what it was. And so they were the same. So then if it's asking for between those numbers, then you would shade in the middle because that's where it's looking for. So so that's how I came up with my answer. And then it came up with like 0.689, right?
So, okay, so to find less than 8, you put in 0.5 and you shaded in the middle part and you came up with what?
Right. Well, because 8 minus 10, what is that? -2 divided by 5. Sorry, I gotta redo the math again. Let's see. 8 minus 10 is -2 divided by 5, and that's -0.4.
Oh, okay.
0.4.
I was doing it
And
wrong.
then, that's okay. And then you do 12. And I just did this to make sure that they were the same, because I remember one week they weren't the same. So, minus 10, and that's, what? Oh, and then divided by 5. And then it's 0.4. So then those are your z-scores, so -0.4 and 0.4. I put that in, and I just put in 1 because it automatically does the other one. And then it's asking for between those numbers, right?
Mm-hmm.
Okay, so then you just shade in the middle of the negative. You just shade the middle because that's where it's asking between those two numbers. And that does not look like what I got on my homework. What? Oh, wait. Oh, I'm sorry. I read that so wrong. Oh, guys, just slap me. Okay, observation is less than 8, so I shaded to the left of -0.4. And then it's asking for greater than 12, so then you shade in the greater of the 0.4. So you actually don't shade, you shade everything but the middle. And then that should get you the answer. 0.89. Did I just confuse you guys? It's really bad now. I'm so sorry.
Well, I'm kind of still stuck on the formula.
Okay, so let me back up. Okay, so you're doing the z. To plug in anything in the applet, you need the z-score, right?
Mm-hmm.
So then
Right.
that's why we're using the z-score formula, or the z. I always call it like zero score or whatever. Anyway, so I went ahead and I plugged in 8 for your variable. So 8 minus 10, because 10 is the mean, right? As it tells us above, and so it tells us on number 3 that the mean is 10. So that's where I got my 8 minus 10, and then the standard deviation is 5. And it didn't, okay, so it didn't say anything about doing a sample, so that's why we don't have to do like the square root of anything,
Okay.
because you're not doing the sample size, you're doing like the parent population. So if it said we were doing the sample size of this population with the mean of 10 and the standard deviation of 5, that's when we would do the square root and everything, like this, like we'll do the standard deviation divided by the square root of n. So because we're not doing the sample size, we're just doing the normal z-score. Does that make sense? Was that where your problem was?
Yeah, exactly.
Okay. Okay, so you're doing like the square root of everything?
Yeah. Yeah, I thought they were
Okay.
all the same.
Oh yeah, so it kind of tricked you there.
Thank you for explaining.
No problem. And then, do you understand the shading and everything?
Yeah. Mhm.
Okay. Okay, so that's how I got negative 0.4 and 4. Alright. Alright, and then, was that E? Okay, so now we're on part 2. Okay. So basically only the thing is important is that the mean is 45, and the standard deviation is 10. And it's normally distributed. And I believe, okay, so now you see how on number 4 it says the sample size n is 4. So now you know that you're dealing with sample sizes. So that's when you have to do the square root. You have to add in the square root of n and everything like that. So who wants to take number 4?
So what do you have to do? Do you use that formula where it has the square root? Is that what you're saying?
Yeah. So because you're dealing with sample sizes, then it's going to be the same formula, same z-score. The only thing that changes is your standard deviation. So it's still, actually number 4 is just asking if it's going to be normally distributed or not, right?
Right.
So the sample size of n is 4, so that's not a large sample size. But however, it says that the parent distribution is normally distributed. So then, according to our rules, then that means it's automatically going to be normal, right?
Okay. Yes.
So simple. I just typed in normal. And then the 5 is asking the same thing. It's just making sure that you understand, as long as the parent function is normal, no matter what the size of the sample is, it's still going to be normal no matter if it's large or small.
Okay.
So the answer to number 5 would be ...
Normal.
Yes, very good. Please let me know if I'm losing anybody. Please let me know, because I don't mind explaining whatsoever. Okay, so number 6, now we're getting into the formula, right? Okay. So a sample of size n is 4 and is taken from the normally distributed 2011 cells data. What is the probability that the observed x is less than 40? So, any guesses on what we do for this one?
I'm thinking 40 minus 45 over 10 and with the square root divided by the square root of, wait, I think I have it wrong.
Nope. No, I think you're right. Oh wait. So you got 40, I forgot what, okay. So right, the mean is 45 and the standard deviation is 10. So, what number are we on? I'm losing my mind, guys. I'm sorry. Okay. So then it tells us that n is 40 and we need to find, so n is 4, I'm sorry, and we're looking for 40. So that's 40, you're right, 40 minus 45. And then we divide that by the standard deviation, which was 10, and then we got to divide that by the square root of 4.
So it's negative 5 over 5, and so that would be negative 1.
Yes, ma'am. And so there we have our z-score. So that is what we can plug into our applet. And that's, so I just plugged in negative 1. Okay, and it's looking for, let's see, and we're looking for that the x is less than 40. So then where do we shade?
To the left.
And then we get the area of 15 or 0.1587.
Great. Okay.
Does that make sense, Corinne?
Sure.
Well, if you have any questions later, feel free to email me. I don't mind at all.
I just don't know how you remember all this stuff. I have to go back and look.
Well, I am a nerd, and so I have to write down everything that I read. And so I have my notes right here, so don't worry. I'm not coming up with it in my brain, I promise. So, okay. So that was number 6. Okay.
Yep.
Are you guys getting an echo on your end?
No.
Okay, I'll just keep going. Oh, it stopped. Okay, never mind. Oh, no, it didn't. Well, oh well, I'll deal with it. All right, number 7. Sample size is n is 4, and it's taken from the normally distributed 2011 cells data. What is the probability that an observed x is greater than 35 and less than 55? So we pretty much are doing the same thing that we've been doing. You take your z-score, and you're still dealing with the sample size, so that's when you'll use the standard deviation divided by the square root of n. And so we're looking for 35 and 55, and I believe those were the same, just opposite. So one was negative, one was positive. Oh yeah. So then I did. So does anyone want, or do you want to set up the formula for us? Anyone?
Do you want me to?
Yeah.
Okay. So it's 40 minus 45. Is that right so far?
For number 7, it says that we're looking for 35 and 55.
Oh.
So then our x's will be 35 and 55.
Okay. Oh boy, I'm having a hard time with this.
No problem.
Okay,
No,
so
you're fine.
35 minus 45. And then it would be 10. Is that right? 10 over the square root of 4.
Mm-hmm.
So it's -2 is the answer.
Yep. And then, Corinne, do you want to set up our second one to figure out 55?
I do have a question. So
Do what? I'm sorry?
I said I do have a question.
Yeah, go for it.
So that's two different equations, right? 35 minus 45 over 10, and then 10 divided by the square root of 4, right?
It's the, I mean, they're two different steps, but they're in the same equation. So, like, once you subtract 35 minus 45, that's like, what is that, 5? Or what is that? 35 minus, that's 10, right?
Okay.
So then, once you get the answer for, like, 10 divided by the square root of 4, once you get that answer, which is 5, then you have to divide 10, which was what you got on the top, and you divide it by 5, which is what you got on the bottom. And that's how you get your z-score. So I solve it like differently. Like I do the top part, which is the x minus the mean, and then the bottom part is where the standard deviation is because you're dividing it.
Yeah.
So I figure out the top answer first so I don't get confused. So I'll do 35 minus 45, and that is 10. So I'll write 10 to the side, divided by, and then I'll do 10 divided by the square root of 4, which is 5. So I'll then do 10 divided by 5, and then that's your answer. Does that make sense? Like that's, so -2. Wait, that should be -10. Sorry, guys. So -10 divided by 5, which is -2. Does that answer your question?
That makes sense, but I just thought from the original, like when we, because over here it says the standard deviation on is 10, so I thought we just put that on the bottom. I thought that was what the formula was for the z-score.
That is for when you're doing the parent, when you're doing a parent population. But in the question, it says we're doing a sample of size, so we're trying to find the sample size. And from our reading last week, that's when it said, you know, the mean stays the same for the sample size, but the standard deviation changes. So then that's when we do the standard deviation, and you add the square root and everything like that. Does that make sense?
Yeah, so, okay.
Okay. So we're doing sample sizes, so that's why we do the square root or whatever. If we're not doing sample sizes, then yes, it would be just 10. You're right. So, okay.
So then the other one would be...
Daddy! Hey! Daddy went to work. Did you get your juice? Yeah. Go drink it! Do you want to play on my phone? Be right back. Okay. Can you go in the living room? Sorry, guys. Can you go in the living room and play? Here. Do you want to do the reading one or this one? Yeah. This one? Okay. All right. Have fun. Sorry, guys. Okay. So, yeah. So for 55, did you figure how to set up that equation, Corinne?
So then it would be just 35 minus 55, and then the answer would be, well, I didn't figure out the answer, but then the answer divided by the square root of 4.
It'd be, okay, so...
Is that right?
We have to, almost, close, so... So you'll take 55, that was right, because that's going to be your x. But then we're told above that our mean is 45. So I think you just got your numbers a little mixed up, but that's okay. So it's going to be 55 minus 45 because the formula is the x minus the mean, right?
Mhm. Oh, okay.
So, and then the equation for the sample deviation is you still take your deviation. So this deviation is 10. And so you'll do 10. So on the bottom of your fraction, so you have, on top you have 55 minus 45. And then on the bottom of the fraction you have 10 divided by, again, the square root of 4. So you still have your 10 in there. So you take the square root of 4, which is 2, and then you'll do 10 divided by 2, and that's 5. So then you have, finally, your bottom number for the fraction, or the, I call it fraction, it's not really a fraction, it's just dividing by. So I hope that doesn't confuse you.
No, I get it.
Okay. So then we have 10 divided by 5, right? Once you get your answers.
So it's 2. Is that right?
Mm-hmm. So then we can then go to our applet and then plug in 2. And it'll automatically put the negative 2 in there. And then it's asking for greater than 35 and less than 55. So where did we shade?
In the middle.
In the middle. Very good.
Okay.
Are we solid on that one, or is it a question?
No,
I'm good.
I got it.
Okay. Good. Okay, what number are we on? 8?
Yeah.
Okay. There are a lot of questions on this little thing. Okay. So, the sample size of, or a sample of size n is 25. It is taken from the normally distributed 2011 sales data. What is the probability that x is greater than 41 and less than 49? So it's pretty much this exact same question. You're just doing it again with different numbers. So how do we set it up?
So 41 subtract 45
Yep.
over
Divided by
10 divided by 10, the square root of 4.
our sample size is, in number 8, is 25. So we'll do,
25. Yeah.
yes. So you do
So
10
25.
divided by the square root of 25. Very good. Ooh, is that awesome? Well, what do you want? You can't go that way anymore. You want to do balloons? Yeah. Oops. Alright, go. Remember the guitar? No. Ooh. Did you guys get the answer for that one?
Yeah.
Oh, I was waiting for y'all. Y'all just said, got the answer. Okay, what'd you get, L'Oreal?
-2.
For number 9. For number 8, what number are we on? 8?
8.
Yep.
Mm-hmm.
And then the other side will be 2 as well. So basically we get the same answer as number 8. Pretty simple. I'm sorry, hold on guys. Penny, what's the matter? Why are you throwing my phone? Here's your reader?
Yeah.
Okay. And can you go in the other room so Mommy can do her class? Alright, here's your reader. Alright, have fun. My husband should be home and he's soon, hopefully. Sorry.
No.
Okay, so we get the same answer for 7 and 8, right?
Mm-hmm.
Yeah.
Okay.
And 9.
Oh, I didn't get the same answer for 9.
Oh, you did? You know what? Maybe I
But we can walk through it. It's not a problem. Okay. So let's see. Sample size. We're doing a sample of size N is 25. And it's taken from a normally just. Sorry. What happened? What'd you say, L'Oreal?
Oh, I was just gonna say I think I copied that question twice. So that's why.
Oh, it's okay. Well, I'll read it to you, and then you can just jot down the numbers that are important. So basically, your sample size N is 25, and then it's normally distributed. Okay. What is the probability that the observed X is greater than 50? So N is 25, and we're looking for greater than 50. So we then plug in 50 minus 45, which is our mean, divided by 10 divided by the square root of 25. And then so square root of 25 is 5, 10 divided by 5 is 2, and then 50 minus 45 is 5. And who would like to tell me the answer of 5 divided by 2?
2.5.
2.5. Okay, so then we can go to our lovely applet. Plug in 2.5. And it's looking for greater than that. So I got 0.0062. Is that what you guys got? Oh.
Yeah.
Is that what you guys got?
Yes.
Perfect. Now, on the quiz, our last quiz from like last week, when we had to do all of this, and it said round to the first decimal place, and it was like this, 0.0062, and I totally got it wrong, so I was like, well, I don't understand what you're saying. So hopefully, did you guys get that answer right? I don't know, maybe we don't have the same questions, but I was really mad.
It was
I don't remember.
Quiz from last week.
Uh-huh. Like, I got a 70 on it. I was, like, not very happy. It was, like, I think it was, or maybe it was less than 6. I don't know. Let me see. It might have been less than 6, actually. Oh, no, I got not less than 6. Then I would have been less than 5.
The homework quiz.
Yeah. Yeah. It was like, anyways, it was like a number like that, and it said round to the one decimal place, and I put 0.0, and I got it wrong. So, I don't know. Did you guys have that question, or no?
I did horrible.
I'm trying to find it. My computer's going really slow.
Oh, that's okay.
Uh, it said round to the nearest decimal place.
Mhm. So it's like it talks about like the 68, 95, 99.7 rule.
Oh yeah, I got that
And
one
did you get it right or wrong?
wrong.
What'd you put?
2.3.
Oh, I had 0.0. I have no idea. I got it wrong and I was like, what? Anyways, so now every time I see like the 0.0068 whatever, I'm like, don't say one decimal place that it says that, because I was like, I got 0.0 and I was like, that can't be right. Like, I don't know. It was interesting. Anyways, back to being on task here. All right, what number are we on? Did we figure
10.
out 9? 10. Okay. So yes, the answer for number 9 was 0.0062. Okay. Okay, sample size, number 10. Okay, so we have our mean is 40 and our standard deviation is 12. However, the distribution is right skewed, so it's not normal. So number 10, our sample size is 4, and it's taken from the right skewed data, sales data. So what is the shape of the distribution?
Right skewed.
Very good. All right. 11, sample size is 40, and it's taken from the right skewed sales data. What is the shape of the distribution?
Approximately normal.
Approximately normal. Very good. Because we have
Yep.
we have a bigger sample, so that automatically makes it approximately normal. Very good. And then what theorem justifies our answer to questioning?
Central limit theorem, but I'm not sure why.
So the central limit theorem, that is the theorem that basically says if you have a large sample size, then you can, like, I'll read it to you. So the central limit theorem says that if the sample size is large, then the x will be approximately normal. So that's the theorem. So that's where we get our rules from, is because of that theorem. So it says if our sample size is large, then our distribution will be approximately normal. So that's where that comes from. Does that make sense?
Yes.
Okay. All right. Number 13. I keep knocking out my headphones. Okay. Okay. Number 13. So a sample size n equals 4 is taken from the right skew 2010 data sales, and you want to know the probability that the observed x is less than 35. Can you compute this probability using a normal probability applet with the information you have? Why? So what do you guys think?
Don't we have all the information we need?
Do we?
There isn't a standard deviation.
So basically, is if we have a small sample size from a right skewed distribution, is it going to be normal?
No.
No.
No. And so the answer is no. We can't solve it, because with the probability applet, it has to be normal for the applet to work. Otherwise, it's not going to give you the right information. So basically, the answer is no, because you can only use the applet for computing probability of normal distributed data. Does that make sense?
Mm-hmm.
Okay. Cool beans. All right. Sample size, number 14, sorry. A sample size n equals 36 is taken from the right skewed 2000 sales data. What is the probability that the observed x is greater than 36.5? 36, sorry. 14. Okay, so pretty much we're setting up just exactly like we've been doing all the other problems. So 36.5 is our x, minus 40, which is our mean, divided by 12, which then is divided by the square root of 36. And then square root of 36 is 6. 12 divided by 6 is 2. And then you get 36.5 minus 40 is negative 3.5. And then, did you guys get negative 1.75?
Let me see here.
For the zero score?
I'm still working on it.
Oh, okay, sorry. I'll give you time.
You go too fast.
No.
Sorry.
Go ahead, Corinne. What were you saying?
Oh, I just said she goes too fast.
She's too smart.
Yeah. It's because I'm a math person and not like an English person or anything else, just math. So math and I get along okay, but English, social studies, science, not so much. Unless there's math in science, then I'm okay, but that's it.
And what is your major?
Marriage and family studies.
And why are you majoring in this if you're good at math?
Well, because math, I mean, well, as long as it's simple enough, I'm okay, but once you get into like trig and geometry and all that stuff, not so good. Algebra, I'm okay, which this is pretty much like algebra, so I'm alright, but if you get into everything else,
I don't know. I like algebra much better than I do this.
oh well. I just kind of look at it as like I'm trying to figure out, make the problem smaller to x, and my z-score is my x, so I kind of like, alright, I got this. So that's why I call like the z-score zeros, because on the horizontal there are zeros on the axis. But anyways, it's really funny. But anyways, okay, so I got negative 1.75. Is that what you guys got?
Yes.
Awesome. And then, what is it asking? I think it's asking greater than, right? 14.
Yes.
All right. So then, so where do we shade?
To the right?
Of what? Of 1.75 or negative 1.75?
1.75.
But what was our z-score?
Negative 1.75?
So, and it's asking, so that is our answer, negative 1.75. So then we have to shade greater than the negative 1.75.
Okay.
That makes sense?
Yeah.
Do you remember how I said earlier, like way earlier, that sometimes it tries tricking you because our z-score is negative and you want to shade just above the positive one, but our z-score is actually the negative one, so you want to shade above that one. Because that's our z-score for 50, right? Or where are we? Or whatever it was asking us what our x was. Oh, greater than 36.5? So our 0 for 36.5 is the negative one. So you want to shade above that one.
Okay.
So hopefully that makes sense. And then the answer you guys got is?
0.9599.
Very good. That's what I got too. Okay, 15. Last one. Yay, we did it. Okay, so a sample size of n is 36. Is taken from a right-screwed 2010 cells data. What is the probability that the observed x is between 37.5 and 42? 15, 15, 15. Okay. So how do we set it up?
So it's 40. Is it 12 over the square root of 36?
Yes, that's the standard deviation part. And then on the top is 37.5 minus 40. Is that what it is? Is that what you got? Okay. Yep.
Wait, did you say 36 inside the square root?
Yes.
Yes.
Okay.
And you guys go ahead and solve this, and I'll be right back. My son's getting into something. Hold on.
Okay.
Annie, what? No, buddy, what are you doing? Oh my gosh. Oh. You are awesome, honey. Annie, you are not. No, but I didn't say that. Here, I'll leave you go. I can't believe you did that. Here, that is.
Corinne, what? Did you get the answer?
Not yet. I'm still working.
You told me that it was over.
I know, Mama.
Sorry, guys, just a minute.
That's fine.
I got negative 1.25 for the z-score.
My son, who is
That's what
2,
I got too.
decided to get a pan out and make eggs by himself.
Well, fun.
Oh no.
Oh my gosh, I can't believe he did that. Like, he cracked them and everything in the pan. Luckily, he didn't turn the stove on, but I was like, oh my gosh.
Oh, how old is he?
2, guys, he is 2.
Oh boy.
Okay. Hopefully, Will be home, like, right now. I'm gonna freak out. Alright. So, did you guys get the answer?
Yeah, negative 1.25.
Okay. And then, so our probability is...
So you just put, on the applet, you just put 1.25?
And it'll all, because they're both the same, like once you figure them all out, they're just the opposite, so one's negative and one's positive. And it's asking, so between those two numbers, so we shade in the middle, right?
Right.
Okay. So then I got,
0.7.
I think that's, wait, that is so not what I got. Oh, just kidding. 1.25. Okay, 7887, right? 0.7887.
Yeah.
Awesome. Okay, any questions or concerns before we go on to our little quiz?
Not for me.
Okay. Hopefully I described everything okay for you guys.
Yeah, thank you.
Okay. Alright, so we go to the group meeting. Lesson 7. Alright. Okay, so whatever the first two questions that you guys want to put, and then I can share a screen, right, somehow?
Somehow.
See if I can figure that out.
It's on the side of your chat. Up at,
Okay.
I think it's the second button with the arrow.
This one. Alright, did that work?
Yep.
Okay.
Yeah.
Awesome. Alright. So. Okay, we got this, guys. I gotta get a pen and a calculator. I'll be right back. Okay. Alright, now you guys will realize that I'm not as fast as you guys think. Okay. So using the normal probability applet to find the combined area under the standard normal curve, that is to the right of z and to the left of that number, round your answer to 3 decimal places. Example, if the answer is this, then you would enter that in the box. Okay. So did it really just give us all the answers that we need and we just need to plug it in?
That's what I was thinking.
Right? Wow. Why can't it be like that all the time? It'd be great. Okay, so it's just 1.358.
Mm-hmm.
1.358. Okay, and but where do we shade exactly? The whole thing?
Middle.
It says under the standard normal curve.
Well, that would be the whole thing, right?
To the
so
right.
it's going to be 1. Oh, to the right of it?
It says
Oh, to
under
the right.
standard
Look at
to
that.
to the right and to the left. Yeah. So under.
Okay, so we don't shade the middle? Is that right?
Okay. Yeah.
Oops. Right, so we don't shade the middle, right?
Right. So it's
You're right.
0.175.
0.1745 is what I got. And wait. And then we round to 3 decimal places. So,
Right.
so then it's 175. There you go. 0.175. You were right. Very good. Then, oh goodness. Who votes to read number 4?
I can read it.
All right.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Round your answer to 3 decimal places. No, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are far that are as far away from the mean as ours in the positive direction. That's
Holy
confusing.
Toledo, what in the world? Okay. So we have the mean is 185. The standard deviation is 26.7. The random sample size is 48. The sample mean was determined to be 177.6. The sample mean. I thought the means are supposed to be the same, though. Now I'm confused.
I don't know.
Find the probability that a random sample of passengers will have the weight that is extreme or more extreme. That was observed in the sample. So are we solving for x then because we don't have an x? Or
Would the x be 48?
oh, you're right. What did I put 48 was? Oh, okay. Okay, so x is 48. Okay. I put that as in for some reason. Weights of random sample of 48. Oh wait, isn't it in though? Isn't that the number of people or not?
I don't know.
This question is a joke. Alright, well let's skip this and we'll come back and maybe I'm going to skip it and we'll just come back to it.
Okay.
Because I don't even know. Okay. Which of the following has a smaller standard deviation if 9 observations are randomly drawn from a population? Okay. The distribution of the individual observations, the distribution of the sample means, or this cannot be determined from the information above. So which is going to have a smaller deviation? So I believe that would be the distribution of the sample means, right? Because that's when you have to do the square root of everything.
I believe so.
Yeah,
So we're going to go with B.
that sounds good.
All right. Number 6. Which of the following rule results implies that the spread in X decreases as the sample size increases? Ooh, I have that written down somewhere. Let me look it up.
I was thinking
Okay.
about large numbers.
The law of large numbers say that a sample mean X will be closer to the mean. So I have what? I have it written down, but I don't have it that it's a rule. Oh, maybe it's just normal distribution rule? Because the law of large numbers is just that the sample mean will be close to the mean of the, oh, okay, so in the first problem, then the means are not going to be the same. See? Okay, that makes me nuts. Okay, so law of large numbers says that the sample mean X will be close to U, will be the mean of the population, the parent population. So I'm not going to say it's that one. It's not the central theorem, and it's not that 69 whatever rule. So I'm going to say it's the normal, just a normal distribution because I have it written under the when X is normal, and then it has all the rules.
Oh, okay.
And then I have it written if sample, wait, let me read. Let's see. Which of the following results implies that the spread in X I have, if sample means of sample size decrease, standard deviation will be close to the mean. Or if sample size means of sample size increase, standard deviation decreases. Is that the same or not? Which of the following results implies that a spread in X decreases as the sample size? Guys, I don't know. I'm confused. What do you guys think? Because I really don't think it's any of the laws. Maybe should we look in reading? L'Oreal, do you want to look up the reading and see if it says anything in there?
Yeah, do you think it should be in lesson 6 reading? Or
this was in lesson 4.
4. Okay. Yeah, I'll look it up. My computer is going so slow though, so it'll take me a minute.
It's okay. I'm looking it up too, so hopefully with 2 people it'll go fast.
Oh, I'm looking at stuff too.
Okay. What? Maybe it's in lesson not 4. Maybe it's in 5. Okay, so not lesson 4 at all. What's week 3? Oh, I guess I just wrote the wrong lesson. So let's do lesson 6.
Okay.
Sorry, guys.
No, it's fine.
Lesson
Well, it says that the normal density curve is also referred to as the normal distribution. So, and that has a spread. I don't know.
Well, I'm just thinking that maybe it is that answer because which rule implies that? Like, let me think. Because like the 68-95 rule, that's talking about how many deviations it is from the mean. And like the 68 whatever percent is 1 standard deviation, 95 is 2 standard deviations. The central limit theorem is specifically stating that the sample size is large. If the sample size is large, then x will be approximately normal. The law of large numbers is that the sample mean x will be close to the mean of the parent population. So none of those really, in my mind, I'm thinking have to do with that. But I have, wait, okay, implies that a spread in, what is the x?
R over X.
Is the x the line over, is that just the distribution? Or?
That's the bar rule. That's the X bar. We talked
I
about
think
in lesson 6.
Or
that means sample mean.
spread and the sample mean decreases as the sample size increases. So when the average decreases, the sample size increases. My mind is not working. It's fried.
Are you sure that it's not the central limit theorem?
Let me look and see if there's anything about that. Other explanation. Let me see. Did you find any explanation under that?
Well, I was confused about those two laws, and so I looked on the internet and I found two definitions for those. And one states that when sample size tends to infinity, the sample mean will be normally distributed. So I don't know, that just makes me think when it grows, the mean will be smaller. Like so even when it grows, the sample size will still be small. I mean what is that? The decrease.
The central limit theorem is saying, so like if we have a sample size of 40, but the parent population was like right skewed, then the central theorem says if you have a large sample size, then your distribution is going to be normal. So I don't know. Okay, hold on.
I will be right back.
Okay. What are you doing? What are you doing? You know what? I just don't even care anymore. I'm just gonna put whatever, and if I get it wrong, I don't even care. So
You can
I
all
guess
put a different
you guys,
answer and then
yeah, because I
Yours
just
was
I don't
right.
even know. Yeah. So I just don't even care. I'm like so over it now. All right. Moving on. Some quiz. All right. All right. Or is she back yet? I didn't see.
I'm back.
Oh, okay, cool.
So what? Did you figure it out?
We're just gonna put whatever each other feels because I don't know. So I'm just guessing, and I'm just gonna guess. I'm guessing normal distribution rule because I looked up all the other all the other rules or whatnot, and they're one-liners. There's no any explanation other than that one line that I've already read like 15 million times. So I'm like,
Okay.
I don't know. Which it could be. I don't know. So I'm just gonna put that one. And if you guys think it's a different rule, feel free to pick whatever you want.
Sounds good.
Okay. So scores on a quantitative portion of the GRE are approximately normally distributed with the mean of 150.8 and standard deviation of 8.8. Use this information to answer questions 7 through 10. Hold on, sorry. Is there a lot of background noise? I'm sorry. Penny, stop. Penny. Wait and watch. Okay. So sorry.
You're
You're
fine.
having a busy morning.
Yes, it's very crazy. And I'm like kind of like screaming at my husband for not being home though. Just kidding. All right. So Diane earned a score of 160 on the portion of the GRE. What is the Z-score corresponding to Diane's score? What? Oh, what is the Z-score, basically? Okay, round to 3 places. Okay, so is this just, we don't need to do the standard or the square root or anything because it's not a sample or anything, right?
Right.
Right.
Okay, so then it's just 160 minus 150.8 divided by 8.8.
Mm-hmm.
All right. .2 divided by 'Did you guys get 1.045?
Yes.
Okay, cool. So we're going to put that in number 7 then?
Yes.
Mm-hmm.
1.045. Okay. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Okay, so then that's just plugging it into our applet, right? Putting our z-score of 1.045 and then shading just above it, right?
Right.
So did you guys get then 148.148?
Let me see here. I lost my applet.
Oh no.
Hmm.
Corinne, did you get that?
I don't have my applet up. If I am going to be
Oh,
perfectly
okay.
honest. I have too many other
Well,
programs
I
up.
can share my applet, right?
Yeah.
Somehow.
Yep. Well, it's up, I thought.
It's up?
I agree.
Oh. On my end
Well, it
or
was,
your
yeah.
end? Oh, I don't know.
Your
Okay.
end.
I don't know how. Oh, if I did this?
It was. Anyway.
Is it up now?
Right now I'm just seeing a black screen, but it was up a minute ago.
Oh, man, what did I do? Nope. Nope. How do I get my face back?
There you go. Now it's up. Oh.
Okay. Does that work? Or now, wait, that's like a lot of windows.
It's okay.
There we go. That should work great. Does that work? Okay.
Yep.
All right. So that's what I got. Does that sound and look right?
Mhm.
Okay.
Yeah, that's what
I'm
I
going to go
got.
with that then. Okay.
So it's 0.148.
Yes. Okay. And then, does it go back to my quiz screen?
Yes.
Okay. I don't know how to work this, so. Okay. All right. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? Round your answer to 3 decimal places. Okay, so we just have to take the average of those and then find the z-score for that average? Is that what you guys are assuming?
That's what I was thinking.
Okay. I'm going to go ahead and do the math then. Did you guys get 160?
Yes.
Yep.
Okay. So, didn't we already find the z-score for 160? Right?
Yes.
Oh, yeah.
This is
Well,
making me think we did it wrong. Oh my goodness.
So
Well-
is it 1.045?
Yep, that's what I got. Either this is really tricking us or we just know our stuff. I don't know.
We'll find out.
All right. Yep. Okay, so number 10. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places. So we just take the 1.045 and put it in the applet and shade greater than. Like, is this really like the same thing?
I don't know.
Oh wait, is it like the sample? Is it a sample? Ah, wait a minute. Wait a minute, guys. Okay, so this is a sample, so then the z-score formula changes.
Okay.
Whew. So now we gotta do like the square root of everything. Oh, that almost got us, guys. Okay, so we'll just do, so 160 minus 158, or 150.8 divided by the 8.8 divided by the sample size of 5. 1, 2, 3, 4, 5. 5, right? Is that what you guys are getting?
Yeah.
Okay. Alright, so 5. I'm going to wring my son's neck. Divided by 5. Did you guys get 3.935 something or other?
I'm still working.
Okay. Still figured out. I gotta go grab my son again.
Okay.
Almost done. Okay.
Did you
Okay.
do an answer for him? I got 2.338.
That is so not what I got. I got like 3.9. Hold on.
So what number goes under the square root?
5.
Okay, okay, that's what I thought. I just...
Oh. Now I got 4.114.
I got 3.935 again.
I
Oh,
like
wait. Oh, wait. Don't do that yet. Hold on. I forgot to do the top part. 160 minus.
I got 2.570. Well, 2.571.
2.337. Alright, we're just going to do this at one thing at a time. Okay, so when we do 8.8 divided by the square root of 5, what did you guys get?
2.236.
Yes. That's what I got too.
Oh, okay, so the square root of 5, you guys got 2 point something something?
2.236.
Okay, and then divide that by 8.8?
3.935. Yeah, 35.
Okay. That's what I got too. So we got 3.935 on the bottom. I'm going to go ahead and do it the same all the way. So 354,796, just to be safe, and then I'll round at the end. And then we do 160 minus 150.8. And did you guys get 9.2?
Yeah.
Okay, so then let's do 9.2 divided by 3.9354796. And it's like 2.3377. Is that what you guys got?
Yeah. 2.338 if you round it.
Right. All right, perfect. So 2.338 2.338. Yay! Okay, what number was this for? 9?
9? Yeah.
Okay. So it's 2.338. Alright. Alright, and then what is the probability that 5 random select students will have a mean score that is greater than the mean achieved by the students in the previous problem? So now we just plug in the 0 for the applet, right?
Right.
2.338. And 1, 2, 3, 4. And it says round to the nearest 4 decimal places, right?
Right.
So did you guys get 0.0097?
Yes.
Okay. Okay, this is sounding a little better. Okay.
Oh.
All right. All right, quiz can get a little easier would be great. All right. Suppose the mean GPA of BYU students is 3.5 and the standard deviation is 0.7. I'm going to write that down really fast. It is well known that this distribution is left skewed. A random sample of n is 81. Okay, so use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable x, which represents a sample mean of 81 students who are selected?
Left skewed?
But we have a really huge. Wait. But we have a large sample, right?
That's right. So approximately.
So then we'll have. Yeah, that's what I'm going to get to.
Okay.
Okay, what is the mean of the distribution of the sample? Okay, what is the mean of the distribution of the sample means for all possible sample size of 81 that could be drawn from the apparent population? What? Oh, the means stay the same, right?
I think so.
So I'm just going to go ahead and put 3.5 then, right?
That's what I was thinking.
Okay.
So on number 11, it just needs to, it would need to be greater than 30 for to be approximately normal. Is that right?
Yeah.
Okay.
At least that's what we've been told for this class. As long as it's greater than 30, it'll be large enough.
Okay, great.
Okay, what is the standard deviation of the sampling distribution of the random variable x, the mean of 81 students who are selected?
Well, I have to be somewhere in 20 minutes, so I'm going to...
Are you leaving, or you just have to be done in 20 minutes?
leave you guys, okay?
Oh,
Okay.
okay. Have a good day and good luck on the rest of this quiz.
Yeah.
All right.
So, yes. So I'm going to go, so...
Okay, we'll see you later. Sorry.
Bye-bye.
Oh, you're fine. Thanks for the help.
No problem.
See you guys later. Okay.
Bye-bye.
All right, bye.
Bye.
So,
All right, L'Oreal, it's just you and I.
I feel bad for you.
Yeah. All right, what is the standard deviation? Is that just meaning we need to solve the bottom part of the equation? Or I don't know.
So that bar over x is the sample size. So 81, oh, I don't know.
Oh!
So would it be 0.07 over the square root of 81?
You know what? I think that's what I'm going to do because that's the only thing that makes sense. Wait. Yeah, that's what I'm going to do.
Okay.
I wonder if this question is worded wrong, because the thing that's messing me up is because it says the mean of the 81 students who are selected. So are we supposed to do the average of 81 students? Or
I don't know.
I'm really confused. I wonder if it's worded wrong. I don't know. Maybe it's not. I'm just going to do what you said because it's the only thing that makes sense. So, did you get 0.008?
No.
You round up? No?
I got
Oh, goodness.
7.778. Let me try it again.
Wait a minute. Oh, I put 0.07. Sorry. 0.7 divided by 0.078. Right?
Are you doing 0.07 divided by 9?
Is it 0.07 or is it 0.7?
Point. Oh,
Oh, it's
0.7.
0.7.
Okay.
I might have messed you up on that one because I read it 0.07. Sorry. So 0.7 divided by 9. So 0.078. Is that what you got?
Yes.
Okay. 7, 8. Man, the group really suffers when not everyone shows up, man. All right. What is the probability that the mean GPA for 81 randomly selected BYU students will be less than 3.3? Okay. 3.3 was the... No, wait. Okay, so then are we finding the z-score then with 3.3 being our x? I think so, right?
Yeah, I think so.
Okay. And 3.3 minus 3.5 divided by, now see, now I'm confused because I don't know if this is a sample or if this is the parent one.
Would randomly selected mean sample mean that it would be a sample?
I don't know, because on all the other questions it kind of said, okay, from the sample of this, you know, and it's not talking about like the 5 students, so I'm wondering if it's not, because the 81 students, that's the numbers for maybe the parent one, right? So then do we just put divided by 0.7?
Yeah, I think so.
Okay, because it doesn't say, like, it doesn't say anything, like there's no sample in there, so I'm gonna assume it's just a normal equation. Hopefully I'm right. Negative 0.2. Okay. What'd you get?
2.857.
And that was negative, right?
Yes.
Okay. That's what I got too. Okay, so then we plug this in to our applet. So negative 0.2857. And what is it? Is it greater than, or what is it looking for? It's looking
Yeah, greater than 3.3.
Okay. So then we're going to shade the middle and to the right. So then did you get 0.6126?
No, I got 0.9979. So for
Oh,
your
wait.
Z,
Oh, because it rounded it up. I don't know how it doesn't, because it automatically rounds mine up. So instead of 0.857, it rounds it up to 8.6 or 86. Does yours do that or no?
for the area part, or
My z-scores?
I put 2.857 in there. Is that right?
Right. But mine automatically makes it negative 286.
Oh, weird.
Yeah, I don't know why it does that. So yours doesn't do that?
No.
Okay, good. Well, let's go off of those numbers. So what was the area then?
So when I shade in the middle and the area to the right, it's 0.9979.
Okay. Yeah, because that's how I kept getting wrong on the key for my homework. 'Cause for some reason or other, my applet rounds it up, and I don't know how for it to not do that.
Oh, that's too
So,
bad.
yeah. So that's the answer then, right? The 0.9, and we round to 3 decimal places, so 0.998.
Yeah. So how did you know to plug that into the applet instead of just
Because it's
negative
because it's
2.87?
because that's your z-score. That's not the probability. When it's asking for probability, then that's going to be like the applet. That's the point of the applet, is that the applet calculates your probability, so that the area on the towards the top, like that's your probability.
Oh,
So your z-score doesn't tell you anything but what's going to be on like the applet. Does that make sense?
yeah. I'm gonna have to remember that. 'Cause
Yeah, that's
I'll be thinking,
well.
oh,
Just
should I?
remember, like the applet is called normal probability applet. So if it's asking for probability, then you need to find your z-score, so then you can find the probability,
Okay.
right?
Yeah.
Okay. Oh wait. 14 is asking for less than 3.3. So, and 15 is asking for greater than 3.3. So let's put 0.998 on the bottom. And then we need to shade in less than on the other one for 14.
Oh. So 0.387.
That's what I got.
Okay.
3 point or 0.387. Okay. All right. Should we go back to number 4? Oh, sorry. What?
Oh, I was going to say, what did you get for number 12?
12.
Okay.
I got 3.5.
Okay, yeah. I thought you had something different down there, but yeah.
Okay.
I forgot about number 4. Darn it.
Yeah. But hopefully it'll make more sense because of the law of large numbers, those can be different. Okay. However, wait. Okay, so the United States Coast Guard assumes that the mean weight of passengers in commercial boats is 185 pounds. So that's going to be our U, right?
Yeah.
Oh, hold on a second.
Okay.
Hey, Cass, is that you? Hi. I'm in class. I'm almost done. You sound crazy. I'm almost done. Yeah, 2 more minutes. I'm so sorry. Okay. Sorry, someone came and so I'm like, I'll be there in just a minute. All right. So, okay, so 185, that's your U, right? Is that what you
Yeah.
say?
That's what I would guess.
Okay. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. So that's our standard deviation. And this is for the big one, right? So it's not a sample, it's the parent. Okay. The weights of a random sample of 48 commercial boat passengers were recorded. So is that an RN because that's saying how many people, right? The weights of 48 people are recorded?
And what were you saying about it?
That's going to be our N, right?
Yeah. That's what I think.
Okay. Okay. And the sample mean, okay, so now we're going into the samples. Mean was determined to be 177.6 pounds. So that's another U that we have, right?
Mm-hmm.
177.6. Okay, find the probability, so we're going to be using our applet, that a random sample of passengers will have a weight that are as extreme or more extreme or either above or below the mean than was observed in this sample. So, I just have no idea.
Yeah.
Like even, okay, so we're using our applet, so that's gonna, okay, we need to find the z-score, but, it's like, maybe, is our x 177.6? Is that our x, maybe? Because we don't normally have two u's in an equation, right?
I don't know. I'm getting really confused with this problem.
Alright, well, I'm just going to see this and see where it takes me. So if I do 177.6 minus 185 divided by, and Hemi, you need to get out. No, I'm almost done. Just give me a few more minutes, please. Go on. Go play with Kathy. Go get her the ball. Go give her the ball. Okay. And are we looking for the sample? Okay, so we're doing the sample, so we're going to have to do the square root of everything. So standard deviation is 26.7 divided by the square root of 48.
Yep.
And that way we're using all the numbers we're given, so hopefully I'm on the right track.
Oh, yeah, that's right.
So I am totally going off of just pure guessing. So if you have any other idea, feel free to jump in. So 177.6 minus 185 is negative 7.4. And